Hi everybody, welcome to your first video lesson for today. This is on vertex form, which is going to be the focus of the rest of this unit. And we're going to focus on parameters a and k, which mean nothing to you right now, but by the end of today, hopefully they should, if not by the end of this unit. Our learning goals: identify how the values of a and k affect the graph of x squared. Remember, for it to be quadratic, it has to have x squared in it and be able to describe the transformations. So vertex form, what is it? This has got to be ingrained in your memory for the rest of this unit. And we're going to refer to it again in the next quadratics unit plus when it comes time for your CCA. But for now, y equals a, x minus h squared plus k. Right off the bat, looks crazy. It's not too bad though, once we get used to it. Kind of know that it's quadratic, or maybe we're thinking it's quadratic because it has a squared in it. And then we have these letters we haven't seen before. A, H, and K. And we're going to focus today on, or this lesson, on the A and the K. And in the next lesson, we're going to talk about H. So let's start, what does a normal parabola look like? So what is something that is y equals x squared? What does that look like? Well, we could fill in a table of values. Negative 2 squared, negative 1 squared, what are those? So negative 2 squared is 4. Now, if you by chance got negative 4, that means that your calculator does not automatically put brackets around negatives. So if you got negative 4, you have to remember, whenever you use your calculator, whenever you do substitution, you should always put it in brackets, and then you should get 4. And then same thing here, put negative 1 in brackets, you get 1. 0 squared, 0. 1 squared, 1. 2 squared, 4. So first thing you should notice, the values repeat like they should in a table of values for anything quadratic. And if we were to make a very quick graph, I'm just going to make it very, very quickly here, because we're about to do something a little bit different. We see that it's a mirror image on both sides. And there's our x, there's our y, and there's x squared. So that's what a normal standard parabola looks like. However, we're going to mess with it. We're going to put it into this equation vertex form right up here. And we're going to mess with a and k to see what happens. Because by all means, no parabola looks just like the one we just graphed, right? We've already had lots of examples of parabolas that open up, down, and don't look like that one. So what we're going to do next is we're going to work with some technology, a website called Desmos. And you don't have to copy this down. These are just some lenses to think through or see through, things to keep in the back of your mind. So I want you to think about what's happening when A gets larger, what happens when A gets smaller, i.e. a decimal. When A was negative, what happened? And likewise for K, you don't have to copy this. We're going to go
so if you want to follow
in depth
along,
later.
you can go to
What
Desmos.
happens to your graph when K is
Just
positive?
Google Desmos.
What happened to your graph when K was negative?
And then graphing calculator. There's nothing to copy.
So next you're going to watch something.
So if you don't want to follow along, do it on your own. Or do it along.
Participate by going to Desmos, or you can just follow along.
Remember,
you don't have to copy
is
anything, just pay attention.
Do an investigation on what does a quadratic look like, and when we're working with vertex form, which is new for today, what do those letters, how do they affect the graph? How do they transform it? And remember, the things we want to think about as we move through this is, what does A do when it gets bigger, smaller, negative, and what does K do when it's positive and negative? So those are the things in the back of our mind as we're doing these. And the goal basically for the rest of the unit is to be able to graph quadratics by hand.
Are you finished?
and to be able to describe them. So what happens to them. So let's just start out here. I'm just going to type in, so remember, quadratics have x squared. So I'm just going to type in x squared. And we'll make this look a little bit bigger. So that's what a standard parabola looks like. 0, 0, and then opens up. And the mirror image, the left side is a mirror image of the right side. Let's do something here. Let's convert this to a table. So if you were to make this by hand, so how did Desmos get those coordinates? Well, same thing that we did earlier. -2 squared is 4, -1 squared is 1, and so on. And we can even add some more points on here. So I'll type in, we'll do -3 and 3. And we know those are both 9. And you can see that these points are the exact same on both sides. Again, anything squared is always positive. So there's our standard parabola. But what we want to know is we want to know what happens when this is in vertex form. What happens when we change the parameters a and k? So I'm just going to put this back up there. Purple, and then let's do this one. So our vertex form, x minus h squared plus k. And what I'm going to do is I'm going to add these sliders, which is cool for Desmos. And we're going to see what happens here. So let's see what happens. And I'm going to put h in there as well, but I'm just going to restrict h to be 0. So I'm going to set them all to be a 0. Okay, and a is going to be 1. But we're not going to touch it. We're only focusing on a and k. So let's see what happens when I hit play on the A parameter. So remember that purple one that you see is the standard. That's just the normal x squared. That's what we're going to compare with the black one to. So let that play through a couple more times. And again, in your back of your mind, you should be asking yourself, what's happening to the graph? So I'm going to hit pause. All right. So A was obviously affecting whether it opened up or down. Hopefully that's what you're thinking. It was also affecting how wide, if you will, the graph was, or how stretched it was, or how skinny it was. So right now you can see the black one, which is the one we're adjusting. It's definitely thinner or skinnier, or looks like it's been stretched like an elastic. It's a little bit more narrow than the normal one. And if we look at the A value, it's 4.91. What we can do is I can move this manually. So as this number gets bigger and bigger, my graph, my parabola is getting more and more narrow. And then as I get closer to 1, my graph starts to widen, 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 and then when it's at 1, it's the exact same. When I go under 1 though, now it's wider. Wider, wider, wider. So again, numbers bigger than 1 seem to make it more narrow. And then when I get to 1 and go a little bit lower than 1, it's wider. And then when I hit negatives, when I'm negative, it's opening down. And the same thing applies as I get to be big negative numbers. It gets more and more narrow. And then as I get to be decimal numbers under -1, it's wider. Okay, so now we know what A does. It kind of makes my graph narrow or wide. Let's see what happens when we hit play on K. It's moving my graph So what are we thinking? It's moving my graph up and down. And what values of k do that? Let's hit pause. So when k is 0, it's right on top of my normal one. And then as soon as I start going up, positive k values, my graph moves up. The purple one, remember, is my standard. My black one's moving up. When I go negatives, my graph is moving down. Again, the purple one's the normal one. And the more negative I get, the more my graph moves down, and the more positive I get, the more my graph moves up. And maybe just for fun, we can play both of these together. It's making my graph wider, narrower, up, down, and flipping it so it's opening up or opening down. So there's our little investigation. And now we're going to build off of that and put it all together into our note. So formally summarizing what we just saw and went over verbally. We're going to summarize the effects of A and K. A by far does the most to your graph. So after we get through A, it's not too bad. All right, so we're just going to make point form notes here. When A was positive, so when A is a positive number, did your graph open up or down? It opened up. So A is positive, opens up. When A is a negative number, do you remember what it did? It opened down. So there's the first two things to consider. Whether A is positive or negative, it controls if your parabola opens up or down. The next thing to consider, when A is bigger than 1, your graph got more narrow or thinner or skinnier, or however you want to think about that. Now you're going to get a word bank on your test, so I'm going to give you the official math language for this. So when A is bigger than 1, you say vertically stretched, which means the same thing as making it more narrow. When A was a decimal, so when A is a number between 0 and 1, i.e. a decimal or a fraction, we're still going to say vertically, and it got wider, right? The math language, vertically compressed. So when A is bigger than 1, stretches it. When A is between 0 and 1, it compresses it. And if A is positive, it opens up. If A is negative, it opens down. The effects of K. Again, A is the only one that has 4 things. K was pretty easy. When K was a positive number, your graph moved up. When K is a negative number, your graph moved down. K is positive, so remember
this. K is positive, moves up. K is negative, your graph moved down. When A did these things, it controlled whether it opened up, down, and whether it was stretched or compressed. In other words, thinner or more narrow versus wider or compressed. These things, along with the effects of A in the next lesson, 100% on a test. You need to make sure you know how to do these things. And these things go hand in hand with the graphing. So once we get to putting it all together and making graphs, these descriptions match our graph. So if you know one, you should be able to get the other. Or these are self-checks for your graphs. So some describing examples. Again, 100% no secrets here. Assignment question, test question. And you're going to see it again on the next lesson, and then the lesson after that again. And then probably again in your review for your test. So let's just come up with some random examples here. We'll say y equals 2. Now we're not dealing with h, so I'm just going to write x minus 0 because we don't care about h right now. And I'll say minus 3. So the first thing you're going to, so you read left to right. So we always read left to right. So the first thing you encounter is the 2. And maybe as a quick reminder here, since we don't have it written, there's our vertex form equation. The first thing we encounter is the 2, the a value. Is it positive or negative? It's positive. So in point form, you want to say the graph opens, and does it open up or down? Opens up. Okay. Now, talking about the value, the number 2 itself. Is it bigger than 1 or is it a decimal? It's 2 is bigger than 1. So if we look at our chart we just made, when A was bigger than 1, it vertically stretched my graph. So vertically stretched. And you can't just write vertically stretched and be done with it. You have to write by whatever the number is. So vertically stretched by 2. Perfect. And then we don't care, so we just did that. We're not doing anything with h, it's a 0. And then the next thing we encounter is the k, right, at the back end. Minus 3. When k is negative, what does it do? Moves down by 3. And don't write moves down by negative 3, that's kind of like a double negative. So by you saying down, you're taking care of the negative. So we see a k value, it's negative 3. We know it moves down. How many does it move down? It moves down by 3. Hopefully it's kind of making a little bit more sense. And more than likely we'll have to do a few more examples. Let's come up with another one. Negative 0.4. Again, we don't care about h, making it 0. And we'll say plus 5. Okay, so again, we're going to go left to right. The first thing you encounter is the negative. That's out front of the a. When a is negative, which way does your graph open? Opens down. Okay, there's the negative done. The next thing you encounter is the 0.4. That's the actual number value of a. If a is between 0 and 1, in other words, a decimal or a fraction, it's vertically compressed. So you want to say vertically compressed, and don't forget by, and don't write negative because we've already taken care of it by saying opens down, vertically compressed by 0.4. Okay, that's done. And then the last thing is the k, which in this case is positive. So you want to say positive k means moves up by 5. And there you have successfully done your first little bit of describing transformations. So that's it for this preview to vertex form and A and K. Make sure that you've reviewed this, go work on the workbook questions that are assigned, and we're going to go over H in the next video, and then we're going to put it all together in your final video of the week, the most important lesson probably of the week, and then you have your assignment to work on.